China's Zhurong rover entered hibernation in May 2022 to survive the harsh winter in Utopia Planitia, with an expected autonomous wake-up in late 2022, once solar power and thermal conditions recovered. As of 2026, the rover remains dormant, with no confirmed reactivation. The key scientific question is no longer simply whether Zhurong will wake up, but what environmental and engineering factors prevented recovery. To investigate this, researchers are cross-referencing Zhurong's final telemetry, high-resolution orbital imagery, and new scientific studies derived from the rover's own ground-penetrating radar data. Together, these datasets provide the most detailed picture yet of the rover's final operational state in the Martian environment that likely caused mission failure. The leading explanation remains power starvation caused by dust accumulation on Zhurong's solar panels. Unlike NASA's nuclear-powered rovers, such as Curiosity rover and Perseverance rover, Zhurong relied entirely on solar energy. Even a modest reduction in solar panel efficiency can become critical during winter when sunlight is already limited and temperatures can fall below -100 degrees Celsius at night. Zhurong required sufficient power generation around its recovery threshold to heat critical electronics before restart. If panel output remained below that threshold, autonomous wake-up would fail. Recent orbital observations continue to show no displacement of the rover, indicating it has remained stationary since entering dormancy. Surface brightness variations around the landing site suggest ongoing dust transport and deposition by local winds. This supports the hypothesis that fine Martian dust may have progressively coated the panels, reducing energy intake beyond recovery margins. New scientific results published in 2025 and 2026 add important geological context. Zhurong's radar data revealed layered subsurface deposits interpreted as ancient coastal sediments and possible buried beach structures, strengthening evidence that Utopia Planitia once hosted a large standing body of water or an ocean-like environment. In 2026, further analysis suggested liquid water may have persisted on Mars until roughly 750 million years ago, much later than previously assumed. These discoveries are scientifically major, but they also reveal that Zhurong operated in a region with complex subsurface layering, varying thermal inertia, and possible ice-rich regolith. Such subsurface conditions influence how heat is stored and released during the Martian day-night cycle, potentially intensifying thermal stress on rover systems. Another factor is local terrain geometry. Even subtle slope orientation affects solar incidence angle, which directly impacts power generation for solar rovers. Small changes in illumination can determine whether battery recharge reaches survival threshold. Combined with dust buildup and extreme cold, this may have pushed Zhurong beyond operational limits. As of 2026, no single failure mechanism has been confirmed. The most likely explanation is a combination of heavy dust accumulation, insufficient solar charging, severe winter cooling, and environmental conditions unique to Utopia Planitia. Although Zhurong remains silent, its mission continues to reshape our understanding of Martian climate history, subsurface ice, and long-term rover survivability. In this case, the rover's silence may itself be one of its most important scientific signals.